Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 3.5a of our Algebra 1 virtual text on inequalities. We're going to be learning how to solve one-step compound inequalities. We're going to be looking at problems like solve the inequality negative 100 less than or equal to negative 10a less than negative 70. We're also going to be looking at how to graph it. So if this is what you're looking for, don't forget to hit the subscribe button so you can get updates to future uploads. We also have 6 practice problems at the end of this tutorial that we'd like you to try out in order to demonstrate that you have mastered the contents of this presentation. Alright, so the instructions for the examples that we're working on are for us to solve the given compound inequalities and graph. Okay. All right, so for question number 1, let's say we want to solve the compound inequality negative 100 as less than or equal to negative 10a as less than negative 70. All right, so what makes a compound inequality? Well, a compound inequality is a combination of two inequalities. All right, there are two types of compound inequalities. You have the conjunction and a disjunction. All right, so a conjunction is an inequality that's presented in a sandwich fashion like this, where you have three-sided inequality combined into one. You have a conjunction, or if you have two inequalities that have the and. All right, so those are what conjunctions are. In this tutorial, we're going to be taking a look at conjunctions and disjunctions. Disjunctions are the ones that have or in them. Okay, so let's go ahead and solve this. Now, this is a three-sided inequality. The goal to solve conjunctions or compound inequalities of this format is to get the variable isolated in the middle of the inequality. Okay, so when we get the variable isolated in the middle, then we have achieved the solved state of this compound inequality in the conjunction form. Alrighty, so let's focus our attention on the middle. What do you notice about the term in the middle of this compound inequality? It has negative 10 times the variable a. Okay, so what we want to do is we want to get rid of this negative 10 by using the appropriate algebraic procedure. So to undo the multiplication, we're going to use the inverse of that operation, which is division. So we're going to go ahead and divide the three sides of the inequality simultaneously by the coefficient of that variable, which is negative 10. Alrighty, so that's the beauty of conjunctions. You can do you can do the whole thing at once. All right, so when you divide, negative 100 divided by 10 is just 10. Now, whenever you divide by negative, that's something you want to remember. You always have to switch the inequality. All right, so less than or equal to becomes greater than or equal to a, and then this less than becomes greater than 7. All right, so we want to write it from least to greatest. That's the standard form for writing inequalities. So we're going to have 7 is less than a, and that's less than or equal to 10. So what I just did is I just reversed the order of the numbers, which results in reversing the inequalities too. Alrighty, so this is a solution to the inequality. Let's go ahead and graph it. So we have a is bounded between 7 and negative 10 with 7 excluded. So we have 7 and 10. Now, since this inequality doesn't have a line, it means 7 is excluded. This has a line that means 10 is included, so it's a closed circle. All right, so a is any number that is in between 7 and 10, including 10. For example, 9 will satisfy this inequality, and 10 will also satisfy this inequality because it falls in the solution region. So ladies and gentlemen, that is the answer to question number 1. All right, let's take a look at another example. Number 2, let's say we want to solve the inequality n minus 8 is greater than or equal to negative 13. Oh wait, let's do something else. Let's do this. How about we do x over 7 is less than 0, or x minus 4 is greater than or equal to 1. All right, it's more like it. All right, so let's go ahead and solve this one right here. So if you notice, this inequality looks different from problem number 1, okay? First thing is not a sandwich inequality, and it has that word or. Okay, so what kind of inequality is, compound inequality is this? When you have the word or, that's known as a disjunction. So for disjunctions, you cannot combine them into a combined inequality. All right, so when you hear the word or, think about disjunctions, and when you hear the word and, think about a conjunction. All right, a conjunction is a compound inequality with the word and, or an inequality that's in a sandwich format, three-sided inequality like we have in number 1. All right, so let's go ahead and solve this one right here. How do we solve it? The goal is to get x isolated in both inequalities, and then we have achieved the solved state. Alrighty, so let's focus our attention on the inequality to the left. You notice that x is being divided by 7, so you proceed to multiply both sides of the equation by 7, and then that yields x is less than 0. Okay, so we've solved this first inequality, and then the next one, to get x isolated, you basically add 4 to both sides of the inequality, and that will give you x is greater than or equal to 5. Ladies and gentlemen, the solution to this inequality is x is less than 0, or x is greater than or equal to 5. Remember, the or inequalities are disjunctions, and they cannot be combined into one inequality. Let's go ahead and graph it. Give ourselves a graphical representation of what disjunctions look like. So we have 0 and 5 as our boundary values. X is less than 0. 0 is an upper bound of the first solution region, excluding 0 itself. Okay, so this is one side of our solution, and then the other one, 5 is a lower bound, so 5 is also included. How do we know that 5 is included? Well, we have that line inclusion line at the bottom, so this inequality is a combination of greater than and equal. All right, greater than and equal gives us greater than or equal to. Alrighty, so since x is greater than or equal to 5, we're going to start from 5 included and everything that's to the right of 5. So this is the graphical solution of question number 2. All right, question 3. Let's say we want to solve the the compound inequality x minus 8 is greater than or equal to negative 13, and negative 4x is greater than or equal to 12. All right, so let's go ahead and solve this. Now, if you take a look at this compound inequality that we have, it doesn't look like number 1, and it doesn't look like number 2 either. So what kind of compound inequality is this? Well, even though it doesn't look like number 1 and number 2, with this word and, we know what kind of compound inequality it is. And basically implies that you have a conjunction. Okay? So the solution will look just like number 1. You can't combine. So think about co as combined and disjunction as disconnected. Okay, so let's go ahead and solve them independently first, and then when we're done solving, we'll use the order of magnitude of our solutions to order it correctly and combine them into one. All right, so first inequality you solve by isolating x. How do you do that? you get rid of the 8 by using the inverse operation. In this case, you're going to go ahead and add 8 to both sides of the first inequality, and that's going to give us x is greater than or equal to -5. All right, and then the second one, to get x isolated, we need to get rid of -4. It's been multiplied by x, right? So you divide both sides by -4. And then what do you get here? X is what? Since you divided by negative, you have to switch the inequality symbol, less than or equal to -3. Now, since this is a disjunction, we have to combine the inequality. Okay, so which one is bigger out of the two? This is bigger, so it's going to be on the right side of our compound inequality, and then this is smaller, so it's going to be to the left. Alrighty, so what does that look like? We're going to combine them. It's going to become -5, the smaller of the two, as less than or equal to, because we have this equality component there, x, and this is less than or equal to because of this one right here, -3. So this is a combination of these two inequalities, and the reason that we can combine it is because we have a conjunction as indicated by this word and. Alrighty, so let's go ahead and graph our compound inequality, our disjunction. So we're starting from -5 all the way to -3. So the solution region is going to be right in the center. All right, since the inequalities have lines underneath them, that means that we're going to have closed circles on -5 and -3. All right, and everything in the middle. And that is the solution to question number 3. All right, so let's go ahead and box that. Now let's go ahead and take a look at the last example, and then we're going to give you an opportunity to try out some practice problems on your own to demonstrate that you've mastered the art of solving one-step compound inequalities. So let's say you have -10x less than or equal to -40, or x plus 6 is less than or equal to 5. Ladies and gentlemen, we have a disjunction situation here. How do we know that this is a disjunction? Well, it's because of this word or. Alrighty, so remember, or indicates disjunctions, and three-sided sandwiched inequalities are conjunctions. So because of this is a disjunction. So our solution will be two disconnected inequalities. We cannot combine disjunctions. So let's go ahead and solve this. So let's look at the left side of the equation, of the set of equations that we have. So this one on the left right here, we're gonna get x isolated. How do we do that? Well, we use the inverse operation. This is -10 times x, so we use the inverse of multiplication to undo the multiplication by -10. So that means we were going to divide by -10 on both sides. When we do that, on the left side we'll have x. Since we divided by negative, this inequality switches to greater than or equal to 4. All right, on the right side, we're going to get x isolated, so we just simply subtract 6 from both sides of our inequality, and that will yield x is less than or equal to 5 minus 6 is -1. So can we combine these two inequalities? That's the question. The answer is absolutely not. Why not? Well, because this is a disjunction. This is an or inequality. So our final answer is going to be x is less than or equal to -1, or x is greater than or equal to 4. Let's go ahead and graph our disjunction real quick. So for the first inequality, the upper bound is -1. So we have a line there, which means inclusion. So -1 and anything less will be our first solution region. And then on the other side, 4x is greater than or equal to 4. So 4 and anything greater will be also part of the solution region to this disjunction. That is a graph of the solution, ladies and gentlemen, to question number 4. All right, let's go ahead and box it and give you some practice problems to work on at this time. All right, so it's now time for you to do some practice problems. We have 6 problems that I would like you to work on. The instructions are the same as the practice problems that we did. You have to solve and graph the solution region. Solve and graph the solution. Go ahead and pause this video presentation at this time. Try out these 6 practice problems. When you're done, click on the play button and we will show you what the correct answers are. Alrighty, welcome back. So hopefully you had a chance to try the problems. Let's take a look at what the solutions are. For the first one, we have a conjunction. The answer is -10 as less than or equal to x as less than -5. Want to graph that is just bounded between -10 and 5. -5. The -10 part is closed and the 5 part is open. So there goes the answer to number 1. For number 2, so disjunction, x is greater than 7 or x is less than or equal to 0. So let's go ahead and graph that. So we have 0. That one has a closed circle to the left. And then 7, there's no line underneath, so that's an open circle to the right. Number 3, we have a conjunction again. Now the solution to this is -1 as less than or equal to y, and that's less than 1. How does the graph of this compound inequality solution look like? It's going to be everything between 1 and -1, including -1, because it has that line right there. Bam, there you go. Number 4, the solution, this is a disjunction also. So we have t as less than -2 or t is greater than or equal to 3. Alrighty, what does the solution look like? Going from -2, this part is less than to the left. And then here from 3 is a closed circle, greater than to the right. Number 5, we have what do we have here? This is a disjunction again, so it's going to be separated. P. For this one, k is less than or equal to -8 or k is greater than or equal to 4. Let's graph the solution to this disjunction right here, -8, closed circle going to the left for the first inequality, and then for the second one from 4, another closed circle going to the right because of the line underneath the inequality, okay? And then the last one, this is another conjunction. It's a sandwich inequality, a 3-sided. We'll have -4 is less than or equal to j, and j is less than 3. Let's take a look at what the graph looks like. So we're going to be sandwiched between -4 and 3 with -4 included. So this, ladies and gentlemen, is the answer to question number 6. So how well did you do in these practice problems? Let us know in the comment section below what score you got. And if you have any questions on any of these practice problems or what we went over in this presentation, just specify it in the comment section below and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of inequalities, do give us a like or thumbs up. Your positive feedback is extremely valuable to us. Do not forget to subscribe to our channel for updates on other presentations such as this. Tons of support resources to help you do an excellent job on Algebra 1, can be found at our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.